All right, let's start working through question 4 on exam 2. We're asked to draw the most stable chair conformations for these cyclohexane rings. So we need to go through and figure out what's going to go equatorial and what's going to go axial based off of the orientations that we are given. So you can see for the first one there, I went through and I put numbers or colors or whatever it is to indicate, which carbons we are looking at, right? So which carbons we are looking at. And so what we need to do then is just start to go through and find our bulkiest group and put that equatorial. So I'm going to start here in the pink. This is just a personal preference. It doesn't matter necessarily which carbon you start at. Just make sure that you're putting your bulkiest group equatorial, and then you can work your way from there. So here's my ethyl group, CH2, CH3. You can draw it out. You can write ethyl, whatever you need to do. And my trick of the trade, remember, is that I always put the hydrogens with whatever group I'm drawing. And I'll show you why I do that in just a second. I move to my chlorine. So the relationship, right, I draw my axial, I draw my equatorial positions. The relationship between my ethyl group and my chlorine there is that they are trans. And so remember, I draw an arrow from the hydrogen to the other group, right? Right, so that hydrogen is above, right? It's got the arrow pointing down. For this to be trans, the arrow from my hydrogen to my chlorine then better be pointing up, right? So I have my arrow pointing up. So up and down, right? Trans. Got it? Okay. So I set my trans relationship between my ethyl group and my chlorine there. Okay. I'm going to leave the arrow. Oh my goodness. I'm going to leave my arrow there on my ethyl group. I'm going to move over here to my green carbon. I'm going to draw the equatorial group out like this just for clarity's sake. It really doesn't matter, necessarily exactly which way it's going. It'll get the point across. All right, so the the hydrogen that's circled here in green, okay, so that hydrogen there circled in green is cis to the chlorine and trans to the ethyl. So I'm going to put my hydrogen here, okay. I'm going to draw a different color hydrogen just for emphasis sake, okay. So remember, up to get to this chlorine, up to get to that hydrogen, cis. Up to get to the green hydrogen, down to get to the ethyl, trans. Okay. All right, so there we go. We got our first one. Good to go. Next. Okay. An expertly drawn chair conformation, as usual. There we go. Pink and blue sounds good. I'll put my blue down there. I'll put my pink up here. It doesn't matter. You could swap those around as long as they are 4 apart, right? 1, 2, 3, 4. As long as they are 4 apart, it's not going to make a difference for this one, okay? All right, find my bulkiest group. We have the choice between a bromine and a fluorine. Bromine's going to be bulkier, right? It's a larger atom, larger radius. So let's start here with the pink. Let's put that bulky bromine equatorial then. Right. So we got the arrow going down to that hydrogen. Looks good. Come over here. If the arrow, we should say the relationship between the bromines is trans. So if the arrow is going down, we better have an arrow going up to get to the other bromine. And that means that my fluorine then is going to be axial. Okay. Wonderful. So take a look at the cis versus trans relationship. Draw your arrows from your hydrogens if you want to, and then assign, whether equatorial or axial. All right, the trickiest one. Let's get this one knocked out here then, okay? So I'll draw a chair. That should suffice for what we need to do. Pink, blue, and green sounds good. Okay. Now this one's going to be tricky because we have to maintain the correct enantiomer, okay? So we're going to have to maintain the correct enantiomer here. So you're going to have to really check your perspective and make sure that you have the correct drawings, your R versus your S on your ring also. So this one's going to be a little bit trickier maybe than where we originally wanted to, as compared to the other ones, I should say. So here's what I'm going to do, okay? What I'm going to do is I'm going to draw a rotation of this ring so that my pink is up here, okay? And what that's going to do, right, that's going to put my isopropyl group here. That's going to put my oxygen here. And that's going to put my methyl group here, okay? And I'm going to draw the chair conformation of this. In reality, you don't have to do this, right? You can approach this in the same way that we did with the other ones, as long as you maintain the relationship, right? So there's pink, there's blue then, right? And then down here is going to be green. Cool. Bulkiest group is isopropyl. We put that equatorial, right? We draw our arrow from our hydrogen down. The relationship between the isopropyl and the alcohol is trans. So we go to the blue, right? There's my hydrogen. There's my alcohol sticking out. Up, right? Up and down. Trans. Methyl group over here is trans also, so we better have a arrow pointing up. So that means my hydrogen here, methyl group here, okay? The relationship between my alcohol and my methyl is cis, right? So both of those black arrows there are pointing up. They're on the same side. Good. They are both trans with respect. Sorry, just dropped my pen. They're both trans with respect to my isopropyl group. Okay. So this one's going to take a little bit of work. You might want to build a model for this just to see kind of what I did. It is not, remember, as with all these cyclohexane rings, this is not the only way to approach this. Okay. It's not the only way to approach this answer. I'm showing you the way that I do these. Okay. That's the way that I've kind of learned to do this over the years. So hopefully you're able to follow along, right? My trick of the trade is drawing the arrows from the hydrogens that are bound to the groups that we're looking at there, the up versus the down arrows. All right, we'll pick this up in the next video then.